you're welcome to my page. In today's lesson, we are to solve this radical equation, the equation that involves surds. We are told to solve for the value of x if 2 minus root 3 raised to the power of x minus 1 is equal to 2 plus root 3 raised to the power of 3x plus 8. If you take a look at the left hand side, the base here, and the right hand side, the base here, we see that they are both conjugates. What do you mean by conjugate? Two surds are said to be conjugates if their product gives rise to a rational number or rational value. How do we know they are conjugates? Looking at the sign here, plus and minus. That is the only difference they have there. Example is when we have root a plus root b. The conjugate of this is root a, just change this to minus root b. So their product always give rise to a real value. Then how do we do that? It's very simple. We use the identity of difference of 2 squared, that is a, the first term, all square, minus the second term, all square. And if you take a look at this, you will see that the square root will take care of the square root will take care of the square. So there we have a minus b. So therefore, root a plus root b multiplied by root a minus root b give us a minus b, and be it any value is going to give us rational here. So the same thing applicable to our question here. So we see that the bases here are conjugates to each other. So let's find the product of the bases here, then we substitute it back to the question. So we have 2 minus root 3 to multiply 2 plus root 3. Let's find the product of this conjugate and let's see what we have. We use the same concept, the difference of 2 square, the first term, which is 2 all square, and the second term root 3 all square minus root 3 all square, and this one square as well. So don't forget the square root will take care of the square. So we have 2 square is 4 minus 3, so we have 1. So it shows that the product of 2 minus root b and 2 plus root 3 rather is equal to 1. So let's ensure that we make one of these two binomial surd. Let's make one of them the subject of the formula, then we substitute it back to the question. That is, we can decide to divide both sides by 2 minus root 3. So we see what we have. So definitely we see that what we have here is just this. We handle this, then we have this left. We have ordinary 2 plus root 3 is equal to 2 minus root 3 all raised to the power minus 1. Remember that we can write our so the same concept is what we use here. So anywhere you see 2 plus root 3, you can substitute 2 minus root 3 all raised to the power of minus 1. So bringing back our question that says this, then we copy down here, then we paste. So this is what we have, and let's solve this together. So anywhere we see 2 plus root 3, this is here we have it, so we can replace it with this 2 minus root 3 all raised to the power minus 1. So we have here we have 2 minus root 3 all raised to the power of x minus 1 is equal to, then let's substitute this. We have 2 minus root 3 all raised to the power of minus 1, but don't forget we still have power 3x plus 8 here. So let's simplify our right hand side and let's see what we have. Then is equal to 2 minus root 3. Then these two powers will definitely be multiplied. So if we use minus 1 to multiply the power there, we shall have minus 3x minus 8. So we see that the bases are now equal. So we can strike out the bases. That is, what do we have here? The bases here, 2 minus root 3. We can also strike this out as well. So we have both to be, the indices will now be equated to each other. So we have minus 3x minus 8. So we can collect our like times normally. So we have x, bringing minus 3 here, we have plus 3x is equal to, then minus 8, bringing minus 1 to this side, become plus 1. So 4x on our right hand side, as x plus 3x give us 4. Then minus 8 plus 1 give us negative 7. So we divide both sides by 4. So we could have our final answer to be x is equal to negative 7 over 4. This is our final and correct answer. If you enjoyed this video, please do ensure you drop your comment and ensure you follow us on all our pages. Thank you and bye for now.